All right, boys and girls, welcome back to the drive-through. As we move on to ellipses 10-4, okay? First of all, ellipses, they have a soft spot in my heart. It's how all the planetary bodies rotate around the sun. It's kind of how the moon rotates around the earth. It's how everything rotates around each other that's different size. And so to that end, it's how particles rotate around nuclei. So like really great science minds, they kind of use this a little bit. So here we go. There's a lot to this. A lot of it is vocabulary, okay? So an ellipse is defined as the set of all points such that the sum of the distance from two fixed points is constant. What the heck does that mean? Well, in here somewhere would be the foci. Now, for the record, if we're talking about the Earth rotating around the sun, the amazing thing about this fact is that, like, let's say that's the Earth. Now, obviously, this is the sun, and it's not drawn to scale, but there's this blank foci in all orbits, and they're not exactly sure what it is. One foci is always the sun, and the other one is like this space, but it has some gravitational pull, so you'll learn more about that from Mr. G. Okay, the major axis is the long axis, okay? So in this picture, that's the major axis, okay? The minor axis is then obviously the distance between the shorter diameter and the longer diameter, if we just ghetto talk it. Okay, there are vertices. The vertices, in this case, in all cases, contain the major axis. So this would be a, 0, and this would be negative a, 0. There are a lot of symmetric properties. So we'll just call it plus or minus a, 0. The co-vertices, we'll put in purple, and that is, we're going to call B. Okay, so 0, B, and 0, negative B. So 0, plus or minus B. Okay? Now, the foci are here and here, and we've talked about those. And for this video, we will just call those plus or minus C, 0. Okay? All right, so we've got A's, B's, and C's. Just remember, A is the distance between the center and so A is half of the major axis. That's important. So A, half the major axis. So then B is half the minor axis. Okay, so now the final thing, and if you are accelerated, I want you to try to figure out why this is the case, but there's no way I could make this video in 20 minutes and have you explain this proof to you. But a really important thing, C squared is A squared minus B squared. So there's some Pythag there, but it's not the way we're used to seeing Pythag. In this case, A is actually the hypotenuse, and that's what I don't have time to really prove to you. But it is something that you need to kind of put to your mind so that you can do these questions right, okay? All right, now let's talk about kind of the general equation for ellipses that are horizontal, okay? So here, this is our major axis. Here's our minor axis. So this is a horizontal ellipse, okay? It is not a function. You can't write it as y equals. It's kind of like a circle. X over a squared, x squared over a squared, plus y squared over b squared equals 1, okay? And since it's horizontal, A has got to be bigger than B. Okay? That's going to give you a horizontal ellipse. The vertices will then be plus or minus A, comma 0. The co-vertices, this is just like we wrote, will be 0, comma plus or minus B. And the foci will be plus or minus C, comma 0. Okay? So that's kind of a repeat, but we added this equation. Now look at the next equation. So now we're talking about vertical ellipses. So now we have x squared over b squared plus y squared over a squared equals 1. Very similar. But now the a's and b's have switched. So A is still bigger than B. And just so you know, they have to be positive, but I don't want to get into too much math. So, how are they differ? Well, like, I don't know. This is basically what you're learning. That's going to be horizontal. Okay? Because that one's bigger. What's going on here? ViewSonic. That's what's going on. If it looks like this, that is vertical. That's what you learned in those last two slides. Okay? Alright. Is that it? Yeah, now we got to do some examples. So, write an equation of an ellipse in standard form with the center at the origin and with the given vertex and co-vertex listed respectively. Okay, I think we can figure this out. So we're going to do number 1 and number 8. Let's sketch number 1. When in doubt, make a picture of it. So we've got this point 6, comma 0. And then we have this point 0, comma negative 5. Oh, I think I got it. Well, that means the other vertice will be negative 6, comma 0. And the other co-vertice will be at 0, comma 5. So this thing has got a low eccentricity, meaning it's kind of circular. Okay? Alright, so let's see. Well, we know, what do we know? We know that this is going to be x squared over a squared plus y squared over b squared equals 1. We just got to remember, is a, yeah, 2a is the semi, so yeah, we can do this. This isn't bad at all. So that's going to be x squared over 36 plus y squared over 25 equals 1. Let's see if these points work. So, does the point 0, comma 5 work? Let's test this point. 0 plus 5, that equals 1. Does the point 6, comma 0 work? 6, 0, they all work. All those points work, so I'm very confident that this is the answer to number 1. Oh, well then I can do number 8 even faster. Okay? Probably without sketching a picture. X squared over 4 plus y squared over 1 equals 1. Not bad. Okay, I can do that. Next, find the foci for each equation, then graph it. Well, how about I do things the way I want, because this is America, and I'm going to graph it first. Just going to sketch it. Okay? Feel free to grab some graph paper from me if you guys want. This, it's going to be a vertically. So let's just call that 0, comma 9. Let's get about the same distance below. Let's call that 0, comma negative 9. How did I get to 9? 9 is the square root of 81. So then this is going to be 6, comma 0 and negative 6, comma 0. and we have some ellipse here. Okay? All right. So, excellent. I'll be right over. Okay? So what do we know? What have we learned? Well, remember, it's like the kind of the Pythag. C squared is A squared minus B squared, and C represents how far the foci are from the origin. Okay? So, we're looking for C. We know our A and B. C squared is 9 squared minus 6 squared. What's 81 minus 36 square root? So C squared is 45. So C is the square root of 45. Now, I'm not even going to get into simplifying radicals. I don't want to confuse you. So we're just going to, for now, for this one, in academic or honors, find the foci. We would say the foci are 0, comma, radical 45, and 0, comma, negative radical 45. And that is, you know, about 0, comma, what's the square root of 45? 6 point something? 0, comma, 6.7, Usonic. 0, comma, 6.7. And 0, comma, negative 6.7. Okay? And does that add up to me? Yeah, I believe that. I believe that. Those are basically the foci of the ellipse. Now, if you're like, who cares about foci? What do they even mean? Well, that's fine. I totally respect that thought. But I left a link here that tells you why the foci are important. So, like, if you're into sketching things, then I want you to watch that video so you understand what the foci. Okay, let's try 15. Find the distance between the foci. The lengths of the major and minor axes are listed. I'm just going to sketch one here. Okay, so this would be like 5, comma 0, negative 5, comma 0, 0, comma 4, 0, comma negative 4. So, find the distance between the foci. All right, well, let's just find the foci. The foci are plus or minus C, comma 0 for this case. Here, A is 5, B is 4, C squared equals 5 squared minus 4 squared. C squared is 9. C is 3. Got it. So this is 3, comma 0 and negative 3, comma 0. So the distance between them is 6. So hopefully you could do number 20. If not, just ask. I'll do another one. I want to get this video going. So let's go ahead and do number 23. Write an equation of ellipse with the given foci and co-vertices. Again, let's just Widmapoi. When in doubt, make a picture of it. So the co-vertices are 0. Okay, so this is going to be a horizontal one. So we know that our foci are at 1, 0 and negative 1, 0. Okay, so C equals 1, B equals 2, and we're looking for A. Well, this isn't that hard. C squared is A squared minus B squared. So 1 squared is A squared minus 2 squared. Okay? So this is a bad way to write it. Okay, 1 is a squared minus 4. So a squared is 5. So a is plus or minus radical 5. Sweet. Radical 5 comma 0. Negative radical 5 comma 0. What's the question? Write the equation for the ellipse. Alright. So the equation for the ellipse is going to be x squared over radical 5 squared plus y squared over 1 squared equals 1. Let's make sure these work. If I put in a negative radical 5, yep, it works. If I put in a 0 for x and a 2 for y, ooh, doesn't work, so I've messed it up. Good thing I checked my answer. I was thinking that B was 1. B is not 1. C is 1. B is 2. Let's plug them in. Alright, much better. So glad I checked my answer, because I would have hated to redo this video. We're at the 16-minute mark and we're going strong. And that's the end of the video. Boom!